All right. Hello, everyone. My name is Suraj. I am the current president of Westwood SWUG here, along with Abe. And Colin here is our workshop leader. Thank you all for coming. If you haven't already, please sign in. And we're just going to go ahead and get started right now. If you have any questions throughout this workshop, please raise your hand. Me or Abe will come around, and feel free to stop Colin at any point to ask him. He'd be happy to go over any of his techniques that he uses over and over. With that being said, we'll just jump right into it since we're starting a bit late. I'll give the mic over to him and enjoy.
There we go. Okay, how many of you guys are aerospace? Mechanical? What about civil? Bioengineering? Math sci? Wait, are you math sci? Yeah, we are. Most of them are aero, nice. But okay. I'm aerospace also, so yes. All right, so you all got the email on Monday with a zip file containing the assembly parts, right? How many of you didn't? Okay, yeah, maybe you can go over and check with him. But inside that file, there should be, let me find it. There should be these 5 files, or these 5 SolidWorks parts. You have the axle, the back and the front, which make up the body of the turtle, the wheel, or actually it's just these 4. I'm just curious, is the assembly in that zip file? I can't remember if I put it. Oh, it is? Okay, cool, yeah. Just so you guys can check at the very end. But there should be 4 parts that you're going to be putting in your assembly. And so, actually, to start, I'm going to be opening a new assembly, and I'm just going to run through all of the knowledge that you need in order to create the turtle assembly that I put in the email. So, to start, I'm just going to put basically any one of these parts in. I'm not actually creating the assembly right now. I'm just demonstrating what each of these mates do. So I'll put in the back, or I guess the wheel and the axle. No, wait, the wheel, the axle. So there's the axle, here's the wheel. And basically, in the assembly, you're going to have the front plane, the top plane, and the right plane. So there's going to be just a coordinate plane for the assembly, but under each part, you're also going to have the front plane, the top plane, and the right plane, as you can see on the axle. And then you also have the origin. And then on the wheel, you should have the exact same thing. So one thing that's always going to happen in every assembly is the first part you put in, it's going to be fixed. See how I get a little error message that says this selected component is fixed? I can move the wheel around because the wheel isn't fixed. It's actually floating. So there's floating and fixed. The wheel is floating, axle is fixed. If I want to change it, then I right-click and then click float, and then that will float the part. And that's how you get them to move if they're fixed. It's just a quick fix for if you're having trouble mating things. Now, on the left-hand side with little dashes, remember that the dashes mean that it's not fully defined. So in order to define it, SolidWorks automatically fixes it for you, and then it's just going to say F. Or you can actually mate it to a specific area of the assembly, such as like the front plane, the top plane, and that's going to define it. And just the wheel, just to demonstrate, I'm going to click this mate button, because this mate is how you're going to get basically everything together in your assembly. As you can see in the example, it's just mating like one part to another. That way SolidWorks knows that like, hey, each time I assemble this assembly, this part is always going to go here because I set it to. So I click the mate button, and there's a lot of mates under here. But we actually, I think on the CSWA you're going to need to know all of these. So coincident, just like on the sketch, it's going to make something on the same plane or just like touching the other thing. So right now I have the mate selection box open, and if I want to make this wheel and this axle be on like the same sort of plane, right now the wheel's higher, I can select the top face of the wheel and then select the top face of the axle. And now these planes are coincident. So that's the coincident mate. The parallel mate accomplishes the same thing, but, oh, sorry. But like, let's say for example, when you inserted your component, this was 90 degrees like to the right or something. And then you wanted this face up here to mate with this face down here. When you click the mate and click this face and that face, and you click parallel, it's automatically going to snap it to parallel. So parallel is just pretty much self-explanatory. Perpendicular does the exact opposite. It's going to be perpendicular to that face. But the two things that I brought up the wheel and the axle for are the or just the one thing is the concentric mate. Any questions so far just on like making something parallel or concentric or coincident or perpendicular? Luckily, they're all pretty self-explanatory, but the concentric mate is really helpful for wheels because essentially does the same thing as if you make two circles concentric in a sketch. So now if I click the check mark and exit out, this wheel is always going to be constrained. Oh, I'm just going to fix this real quickly. It's always going to be constrained to just like move along. Like I can rotate it, and I can move it up and down, but it's always going to be concentric to this. You see, like it just rotates. And now, I'm going, oh, I did not mean to do that. And now I'm going to do the concentric mate from the wheel to the end of the axle like this. And now once I press the check mark, it should only be able to rotate now. But this is still going to have a little dash next to it, because as you can see, it can still rotate. And remember, one thing that we can do in the assembly that I briefly brought up at the beginning, but if you want, because right now, no matter how much you rotate this wheel, the center of mass is going to stay the same, right? Because the wheel is just rotationally symmetric. But if I really want to get that check mark away, what I can do is I can select mate, and under the part tree right here, or the feature tree, I can select like one of the planes of the wheel, so the right plane, and then select like one of the planes of the assembly, and then have them be parallel. That way the wheel can't rotate. Just a way of doing that. And then the wheel is not going to have a little check mark next to it. It's fully defined. You can't move it. Any questions on that? Because that was a lot of information at once. Awesome. Now, let's see. So we have a couple more mates. And this one is similar to parallel, except it's just a distance one. So if I click both these faces, oh, let me delete the mate that I made earlier. Or edit it a little bit. So instead of making it coincident, maybe I want to set it like 10 millimeters, like this. So now this distance between both of these faces is 10 millimeters. And I can flip the dimension, like so. And I can even change what side of the part is being aligned, sort of. So if I flip it like this again, then I can flip it around like that. So that's the distance mate. And then the angle mate is the same thing, except you can just make your faces angled. But I want to see how you guys try that out on the assembly. So that's one thing that could be fun to figure out. I think they have all the, you guys have all the knowledge necessary to do the turtle assembly now. The instructions are on the sheet. You guys have this, right? It should be on the PDF. And just like as an example for the first part, I just tell you, because on the CSWA, it's going to tell you what to mate, and it's your job to kind of pick out which part of that part, or like which feature of that part you're going to have to mate. So for example, like I just say like make this coincident, and then the two things you're going to want to make coincident. And yeah. So any questions on how you guys want to start the assembly? Awesome. I think we're good to let them start. Oh, good question. I assembled this, so I didn't. 15, 20 minutes? 15? Okay. Oh, yes. Wait, let me. I'm going to Coconut Mall. Oh, actually, I'm going to do the complete. I'm going to put the complete assembly on that way. They can kind of see what it looks like. Yeah. So you guys are going to want to go up to the top corner and then just click New and Assembly when you make your assembly. This is just so you can check your work. But how long did I set it to? There you go. I think that's how it should look. What? Yeah. I made it in 6 years. It was part of the school. I would like to make an announcement on the document. So this right here in the parentheses where I say, at this point, the wheels and axles should only be able to spin without any other degrees of freedom, that should be actually below bullet point 10, which is when, because each of these are going to make the axles and the wheels, this one's like the front, or the back wheels, and this one's the front wheels, but this comes after that. So not after 8, it's going to be after 10. There we go. But that's just like a sanity check sort of thing. It's not actually like a step in the assembly. Oh, I didn't tell them where the width mate is. Okay, also, I did not tell you guys where the width mate is. So if you go into the mates, it's actually an advanced mate. So you click here, up in the top left, and width is right here. And then like, this is gonna be like the center of what you're trying to make width. So like, it's gonna make whatever these two centered between like maybe these wheels, if I can find them or whatever. So like, that's what this is gonna do. Does that make sense? Like a width mate, it just makes it like centered completely. Yeah. But yeah, it's under advanced. All right, does anyone still want more time? Because I'm going to start going over the assembly now. Awesome, cool. So, in order to start it, I'm going to start a new assembly here. And the first thing that it's asking of me is the turtle back. So what I'm going to do is I'm going to browse for the turtle back and then put that in the assembly. And the way that I made this part, the front plane, is actually kind of, oh. Can I what? Oh, I forgot the music was on. I don't know why. Might be. Okay, so, yeah, anyways, if the music was too loud on the recording, I started a new assembly, and then I put the turtle back in because the document calls the first mate to be the turtle back, because that's what everything's going to be modeled around. Now, right now, it says it's already fully defined, and that's because it's fixed. SOLIDWORKS just fixed it because it does that. And the first mate is I'm going to select the bottom of the turtle back to the top plane of the assembly. And if I look just on kind of like the isometric view of this part, which isn't on the document, I should have put that on there, but the bottom is just, like the bottom of the part. That's why I kind of had it in quotes. And the way you do that is by selecting the mate, and then you click the bottom, and it's going to be mated to the top plane of the assembly. So right now I can't select it because it kind of got rid of this. So what I'm going to do is I'm going to go under the feature tree and click the top plane right here. And so now, once I select the top plane, it's going to be perfectly aligned with it. And I can move it around the top plane, just like so. But if I go back into the isometric view, you'll see that there are still 2 degrees of freedom. It can move along the x direction and the z direction. So for parts 2 and 3, I'm going to make the front plane of the turtle back to the right plane of the assembly. So I'm going to click the mate and go back under to the turtle back, click the front plane, and then I'm going to the right plane of the assembly, which is all the way up here. But one thing that's different about this, about the isometric view for this, and then this part, is the tails on this side. And so the way that we flip the alignment is just by doing this. Any questions? Cool. And now, like there's only 1 degree of freedom, because it's fixed along the y direction and fixed along the x direction. So now I just need to constrain it in the z direction. And the way I do that is mating the front plane of the assembly to the front face of the turtle back, which is shown to the right in orange. So I'm going to select this, and then select the front plane of the assembly. And now it's fully mated, and it's fully defined, and it can't be moved. Any questions just on how I got that first part in? Cool. So now I'm going to put the front axle into the turtle back. And so I need to insert my component, browse for just one of the axles, and then put that in there. It's not going to be fixed. It can float, move around. So what I'm going to do is it calls for a concentric mate. And so I'm going to select this right here, just the outside of the axle. And then because it's the front axle, I'm going to do it with the front hole. Then I select check mark. So now it is fully mated to, or it's not fully, it's just mated to the hole here. And it can still spin around. As you can see, the grains are still spinning around. And it can also move out this way. But 1 of the degrees of freedom is fixed. So now, why did I do it in, okay, well. Anyways, I'm going to mate the wheels to the axle now. For some reason, I have the back and front axles and the wheels mixed up on the document. I'm going to insert components, and I'm actually going to have to do this twice. So turtle wheel, and then insert components, turtle wheel. I feel like there's a quicker way to do this, but I just put them both in by themselves. So now I'm going to select the concentric mate and mating the two wheels, I guess of the front wheels with the front axle. So select the inside here with the inside here. That's the first. And the inside here with the outside of the axle here. So now the wheels are constrained along the movement of the axle, which is constrained into the hole in the back part, which is fully defined. Therefore, the wheels can't move except along this direction. So now I have a concentric mate with the back wheels. So I do the exact same thing with the back wheels. And so I'm just going to run through that again. There's this. Turtle wheel. And then turtle wheel. So I'm going to select the concentric mate, select this, and select that. Then select this and select that. Then select this and select that. And now it looks a little convoluted right now, but everything is technically where it should be eventually in this one dimension. So now what I'm going to do is I'm going to the coincident mate, and I'm going to make the outer surfaces of the front and back wheels mated to the outer faces of the axles. And so basically what that means is I'm going to take the outer surface of this wheel and the outer surface of this axle. That way they are sitting flush like so. Any questions just on that? And then I do the exact same thing with this. And this. So these two. Hello. And if you can't access like a face here, you can always just move this out so that way you can see it. This face with this face. And it can also be the edge over here. Like I just accidentally clicked the edge, but it's going to accomplish the same thing because that just means the edge should be on the plane of the wheel and it's not going to like move. And so now the wheels are mostly done because they're along the correct axis and they have the axles mated to them, but according to the turtle part, they still can move. Oh. I just use shift arrow to go 90 degrees, if any of you guys are wondering how to do that quickly. And now I'm done with these 8. So now here's the little bit of a complicated part because we're going to do the width mate. And the way this works is it's going to make whatever two faces exactly the same distance, like the middle of that plane, or the middle of those two, is gonna be on the same plane as the middle of the others two, and I will kind of like visually show that. So the width mate, you go to advanced and then click width. This is the first part. So the turtle. And then the second thing that it's going to want to sit between is this face and that face. Or you can select the inner faces of the wheels. It can really be either. Because this face and that face, the mid plane between them is the same as the mid plane between this face on the inside and this face on the inside. So on the document, I have the orange faces, which are the insides of the wheels, but it accomplishes the same thing. And now whatever distance this is right here is going to be the exact same distance as this. Any questions on the width mate? Yes, because they're the same distance away from the center of the axle. Like the center being like correct, or just like right down here. So now you can't really do anything except spin. And if I didn't specify this in the document, but if you really don't want them to spin at all, you can select mate, go under one of these wheels, I guess, select one of the planes, like this one, and then mate it to like the top plane, then that'll prevent the entire thing from rotating, or at least this one. But then you have to do it for all 6 parts, and it's kind of tedious. But, yeah. Anyways, oh. I need to do that with mate one more time, because I undid that. This, that, and then this, oh, come on, this, with this, and that. So there's a with mate one more. Hold on. I may have accidentally created a mate already. Okay, that was weird. One second. With mate, and then there you go. And then, in order to teach the distance mate, instead of with mating the front wheels, I actually made it so that the front wheels are 1 millimeter away on one side, and the side that is the 1 millimeter away is just this is actually flipped, so I guess like, hold on, I'll try to get to that view. It's up like this. So in order to get that 1 millimeter away, I click the mate button, I click this face, and then I click this face, and SolidWorks is gonna attempt to make a coincident mate, because that's just the default, but instead we're gonna want to click this distance mate right here, and I wanna select 1 millimeter. And then this distance right here is 1 millimeter away. Any questions so far? Awesome. And now this should only be constrained to move rotationally, this too. And now, yeah, the wheels and axles should only be able to spin with no other degrees of freedom. So that was the one spinning direction. And now we're going to add the turtle front piece in, because we're going to mate the outer surface of, we're going to mate the pin of the turtle front with the hole in the turtle back. So this hole right here, and we're going to browse, click turtle front, and just plop it in. Now this is also kind of not in a great place, I guess. But basically, in order to solve that, you click mate, click this outer face of the pin, and the inner face of the hole. But you're going to see that it doesn't want to mate correctly. Just flip the direction. And that's along here. It just says mate alignment, and it right here, that means the parts are on the same side, and this just means the parts are on the opposite side. If it's not to your liking, or just however you, or not to your liking, but like however you need it for the assembly, just flip it by pressing the other one that's not dark. And now this only has 1 or a couple degrees of freedom. So now, this is the coincidence. So I'm going to make the turtle's front's face to turtle back's. Oh, I didn't. Okay. I meant to have put this right here. So in order to constrain it, just like on this area, I guess it should be sort of like top face. And we can send out an updated version of this after. But so I'm going to mate right here with this right here. And that's going to prevent it from moving up and down. I don't know if the hole and the peg are the exact same distance. That's the thing. Because, so if I undo that mate right there, and let me just see. So if I evaluate this, I go to the measure tool, and then I go from this face to this face, or what? Oh, click to measure. This face to this face. It's going to be 12.7 millimeters. But let me exit out of that and then try the bottom face up to here. Okay, so that's also 12.7 millimeters, so that would have been good to do as well. But yeah, general rule of thumb is do exactly what the document says. This is my first time making an assembly document, so it's not perfect, and there are some typos on there, or like not clarifications. But if on the SolidWorks exam, you're going to want to do exactly what the document says, not to like infer a relation. What? Oh, thank you. I'm proud of it too. So then you mate this to here. I tried to clarify what mates to do in enough detail that you could do them without being too specific and like giving away sort of everything. But ultimately, you're going to have to do most of it. So after this is mated, now it can only spin. And so if you look from the top, it just kind of does whatever. And now this is the last mate of the assembly, and it's the angle mate. So you want the angle between the turtle front and the turtle back to be 150 degrees as shown here. So I'm going to click this and that. And that's going to make them coincident here, but instead I'm going to make an angle. So right here, I'm going to click 150. And if it's not perfect, like maybe the dimension is flipped, it's on the other side or something, and it'll be 150 from here to here, kind of along the left side, or 150 from like back here all the way over here. But basically just play with the flip dimension and the flip alignment until you get what you need. Because now, if I look at this right here, that's 150 degrees. So now this turtle assembly should be done. And this shouldn't move, this shouldn't move. These can only rotate. So now I'm going to go to find my center of mass. And it's in the same area as before for the mass properties. So right now I need to rebuild it just so SolidWorks like recreates everything exactly how it should be. And it should be 1.05, 28.00, and negative 37.35. And that's what we got. Did anyone not get that or get very close to that? What I think might be the issue is, did you make sure to make this 1 millimeter and to width mate this and then make this exactly 150 degrees? Because the X direction is, as you can see on the bottom left, it goes from the left and right of the turtle. So it just may be an error on in one of those three. Yeah. Oh, well, I hate when it does this. I'm gonna spin it around in order to like sort of align it, and then when you click this, it should be fine. Ah, there we go. And then what SolidWorks is going to do on your exam is it's going to tell you to actually edit one of the things on your assembly. So now instead of making it 150 degrees, you have to make it 170. So I'm going to go back into this and edit it and change it to 170. And then it's going to ask you to find the center of mass again, which is negative, or actually 0.3228 and negative 37.008. Shouldn't be, oh, the z-axis, yeah. So that's exactly what I get here. And then for the last one, change the angle, oh, okay, this should be 180 degrees. But essentially what you're doing here is just making it so that it's straight on. Come on. Like this. And now the center of mass should be negative 0.8, 28, and then negative 37.05, which it is. Any questions on the assembly? Yes. So the origin for the system is simply where all three of these planes line up. So it's going to be kind of underneath this turtle here and just to the bottom. So like basically right on the center of this edge. That's where it should be. Yes. So yeah, you need to make sure that whatever the like kind of base part is, so in this case it's the turtle back, is perfectly mated to everything else, or like the assembly, because it's going to tell you like on the CSWA it's going to say like mate this origin to the other origin. So like mate the turtle back origin to the assembly origin, for example, and that's like that might be how you do your alignment. Okay, I can go over and check in a second. I don't know the point. I don't think it would. Oh, it's 1% error. So that's not 1% error.
So if you want like a quicker way to align the origin of your part and the origin of your assembly without having to mate like planes, so for example, if I was to insert a new part here, so insert component, existing part, and then say I was to like, I don't know, put another axle. So instead of clicking down, I would just instead press the check button, and then that would automatically align the origins together. So, I mean, in the example, if it says mate the origins, instead of having to go through mating each and every one of the planes, you just click OK instead of clicking in the center. But yeah, that's just really quick. So I think now we'll just open it up for questions. If you guys don't have questions, we'll move on to another part. We'll see how much we can get through it. But yeah, does anybody have any questions at all from these past 3 days? I know it's a lot of parts, a lot of features. But yeah, we can go back to any part, any sketch, anything you guys had questions with. Okay, so you go to evaluate, then mass properties, or rebuild, and then it just says center of mass millimeters. So it's like right underneath where it says like your mass for the part, but then it's just center of mass.
Colin, do you have any files downloaded for the workshop? In here? right, hello. All right, so what we're gonna do now is we're gonna try a bit more of a complicated part. This part looks very scary. In fact, it is a bit scary. But do me a favor and just take 5 minutes to look it over and think through how you would model it. Think about where you'd want to draw your sketches and where you would want to do your features and extrudes from. And then this part is also in the same document that was emailed out to everyone. All right, that's about time. Real quick before I begin, I'm just curious, what do you guys think will be the most difficult part about starting this? Or where do you think we should start this? Okay. I'm assuming you mean like you're trying to say this part right here? Yeah. Okay. Any other thoughts, ideas? Are you saying start from like right here? Yeah. Okay, interesting. Other thoughts, ideas? Yeah. Are you which L? Like here? Okay, so that's this, right? So one way to read this, I think it's if you're not super sure how to read the drawing, which can be complicated, it's always important to refer these section views and stuff over to this isometric, because right here, this looks like a straight line, when in fact, it's more of a triangle. And you can only figure that out by looking at this angle, sort of seeing a bit of it here in this image, and then assuming based off here. So you have to make quite a few assumptions when you look at a drawing sometimes, and that includes assuming some of the dimensions that'll be constant throughout. And I'll get into that when we start doing this. So we're going to be starting by modeling this bottom base here. The reason we do this and we don't start with this U is because this is a flat base, and we want to start on a plane. This is more offset from a plane, so it's going to be a little bit more difficult to constrain everything when we start modeling. So I'm going to get started here, and what I'm doing to switch back between them, I'm doing Alt-Tab, and this just switches my windows really quickly. So I'll start on the top plane, and I'm just going to create the general outline of this shape right here. So I'm going to always start at the origin when you're doing a rectangle, and I'm going to go across and then down. And then I notice there's a small gap for an arc, so I'm just going to leave a gap here. You can always trim it later, but for me, I like to get as close to the shape I'm trying to go for as possible when I do the general outline. All right, so there's another arc right over here. So for reference, I'm looking at this drawing, and I'm trying to model the base here. All right, going across. I'm leaving a small gap here for the arc, and then I'll do the same right here, leaving this gap for the arc. And then going ahead and here, and so notice when I do this that all of these pieces are vertical and horizontal. You can tell because it has this little green icon. If it doesn't, you might want to click left click it and then click vertical or make horizontal, just so it has a constraint and you don't run into an issue later where instead of trying to dimension two things parallel to each other and a distance, you get an angle. And in this case, we see this is off-centered, off the side. We want to make sure that this is in line with all of this. So we can left-click here, hold Control, left-click that piece, and then go ahead and click Make Collinear. And that's how we make two lines in the same line using the constraint. All right, everyone's good so far? All right, now I'm going to add these arcs in over here. I'm going to be using, we'll say, 3-point arc for this. You could use centerline and tangent, or maybe centerline and 3-point both work. But I'll stick to 3-point for now. And looking over here, it's pretty easy to tell that this is meant to be half of a circle, a semicircle. So you want this, this point right here to be in line with both of these lines, if that makes sense. And then same for this side. One really neat thing you can do in SolidWorks is you can set two arcs or lines or circles or shapes to be equal in dimension by left-clicking one of them, holding Control, left-clicking the other, and clicking the equal sign. So now no matter what I make one of them, the dimension will be attributed to both. So if I go Smart Dimension, I dimension this to be, I believe it was 0.25. Both of the dimensions change for the arcs. And I got the 0.25 from over here. All right, everyone following along so far? All right, cool. Now I'm going to add the arcs down here. There's no very clear dimension saying what these arcs are, So when that happens, you want to go ahead and assume that all the dimensions are going to be the same for the type of arc. So they're all going to have a radius of 0.25. So down here, I'm going to go ahead and do the same type of arc I did before. And as well here. I'm going to go ahead and I'm going to make all these equal with each other, just so I only have to dimension one of the radii, since they're all going to be the same. And then I want to make sure, as well as I did before, that this is in line. It looks like a quarter circle, so I'm going to assume it's a quarter circle, and this point then needs to be at the corner here. So it needs to be in vertical line with this one and horizontal with this line. Does that make sense? All right, so I'm holding shift, click both, make vertical, click the center one here, click this point, and then make horizontal. And I'll do the exact same thing on this side. All right, is everyone here so far? Or who is not here yet? All right, if you need some help, yeah. All right, let's keep going. And remember, I can slow down at any point. It's just a lot, so I'm going to keep going until someone tells me to slow down. But I'd be more than happy to slow down. Sorry about that. Okay. Let's see. So now we have a few options. We can add the fillets, we can add the slot, and we can also dimension the top and bottom. I'm going to go ahead and do the top and bottom, get the overall big dimensions down before going into smaller details within the shape. So this side right here is 2.5. That goes from down here to the top. This is 2.5. So now this messes this part up, but that's okay. We can easily just drag it down, and it'll be fine. And that's because we haven't dimensioned the left to right yet, and that is going to be 5. One thing to note is you always want to do the dimensions of a rectangle before you add the fillets in, because that'll just complicate how you do the dimensioning. So fillets should be the last thing you add to a sketch or to a part after you model it. So now I'm going to dimension the 0.75 that you see right here. This is the distance from the center of the arc to the top of the base. And we know that these are still going to be in line and they're equal. So I'm going to go ahead and click this center point here, center of the arc, then hold shift and click the center of the arc here and make them horizontal. This again just makes the 2 points in horizontal line, so if one goes up, the other one changes as well. So if I change this to be like 1.5, for example, both of them shift up and down. And we want to do this to limit the number of dimensions we have, because when we have everything constrained to itself, then it's really easy to make modifications. Instead of changing like 10 dimensions, you could change 1. So what we see here is that the sketch is still not fully defined, and that's because these arcs, I mentioned it before, but we want this center point to be in line with the top and bottom, but we haven't set that yet. We haven't exactly told SolidWorks that we want this to be a certain way. So let's do that right now. We're going to take the center point, click it, hold shift, click this point here, and make it vertical. That puts it in line. And you know now it's fully defined because the entire sketch, or at least this part of it, is black. Blue means undefined, underdefined, and black means fully defined. So same idea, center point, hold shift, click the top point, and click vertical. So now the sketch is fully defined. It says also in the bottom right corner here, which is hard to see, but it says fully defined. Is everyone up to here so far? Or raise your hand if you're not here yet. Okay, very cool. So a lot of this should be review if you came on Monday. We're just using the simple features, simple sketch tools we learned then, and applying it to a little bit more of a complicated sketch. Now we're going to add the slot here, and then we're going to go ahead and add these center lines that are going to help us dimension this half right here. So the slot is going to be this tool over here. We're going to drag it over. That's fine. We're going to dimension this. This is 3 inches. And the distance from the top. Okay, so let me show you guys what happens when you don't have it in parallel or horizontal. Let's say I assume that this was horizontal, and I'm trying to dimension the distance from the top of the slot to the top of the base. I click both, but now instead of getting a distance, I get an angle. And if you don't notice that this can then screw up your part later on. So you want to make sure that this right here is horizontal. And now when we go ahead and smart dimension, this is going to be a dimension, a distance, rather than an angle. One another assumption that we have to make here is assume that it's all center. Because we see a center line going down the middle and it looks like it's centered, that is an assumption that we can make and say that this part right here is centered in the overall base. So I'm going to create a center line from the midpoint of the top to the midpoint of the bottom. And I'm going to put this part right here on the point. So taking the center point, holding shift, clicking this line, and clicking make coincidence. Now we have a couple more dimensions to add before this piece is fully defined. We have to add the dimension of top to bottom, and that is 0.25, and the dimension from the top of the slot to the top of the base, which is also 0.25. So smart dimension from here to here, that's 0.25. And then from the top of here to the top here, that's also, oh, okay, I guess that's already dimensioned. Oh yeah, I did that here. So we're good. So now everything is, once again, fully defined. Now we're almost done. We need to add a couple more items. And one of that is the center line that goes from the left to the right. Is this midpoint? Is this line, the center line here, left to right, midpoint, like in the middle? Okay, so we're not sure right now if this line is actually in the middle. So we're going to look at the other drawings and see if this can give us some more information. Okay. Where's the dimension for it? The center of this line right here, from the top or bottom. Oh. Okay. So it is a center then. Okay, wait. Is it? All right. Okay, so we're good. So as you saw, we looked around, we didn't see dimension, and we're just going to go ahead and assume that the center line right here is going to be the center of the rectangle that we've been working on. So this rectangle, going straight across it through the middle, is going to be a center line. So from this midpoint, or I guess more so from the midpoint of this center line to the end. Notice again, it's still a green horizontal line. That tells me that this is horizontal, and that's good. Yeah, I'm going to do a circle afterwards. Okay. So looking at this, now we're going to work. We notice that there's symmetry. This is important because that means that we only have to do one side, and we can mirror it all over the middle. So we see this detail. We're going to move here and now work on creating these two shapes. Does anybody notice something that might make our lives a little bit easier with these shapes? Do we think that we have to model the entire thing ourselves, or is there some easier way we could do it? Partially symmetric, okay. Good observation. Take a look at what Abe said. So we have a 0.25 here, a 0.25, a 0.25, all the way around. What might that indicate? Alex. Well, actually, it is offset entities. Yeah, with a little bit more of like, you add a little more to offset entity after you make it. But when you look at something and you see the same dimension going all the way around, and you look at this shape and it looks like it's similar to this radius, and that it just seems like it would be easy to do with offset, I recommend trying to do it that way because that will save you a lot of time than modeling it and then dimensioning each side and then adding the fillets later. So we're going to go ahead and we see this dimension right here. We need to build the outside of it because if we didn't offset right now, we're offsetting it from the entire shape and we're not going to get what we're trying to achieve with these sorts of shapes. We need to add a line going this way and a line coming out down here. Luckily, we have this dimension. So it says right here, 45 degrees off here. And then this bottom right one is also 45 degrees, as we see in the left image here. So we're going to add two center lines. Or for this case, because I think I'm doing offset. Can you offset center line, or is it just solid? Okay, cool. So I'm using a center line right here, or construction line, whichever one you want to call it. Start from the center, and we're going to go out 45 degrees. Now, I'm purposely not making it 45 degrees when I draw it, because then I have the ability to make the dimension myself. Otherwise, I might run into a constraint that I don't realize, and that's going to cause more harm than good later down the road. So I'm going to go ahead and smart dimension this to be 45 degrees off this line right here. And same for the bottom. I could have mirrored this if I wanted to, but it's just two lines, and so it's really simple for me to dimension both of them. And all right, now we're ready to go ahead and do the offset. So I'm going to go to offset entities, and I'm going to click all these lines that I want to offset. And it says 10 millimeters right now. I've been working millimeters. We're doing 0.25 inches. So just make sure this is inches. I hope that I've been working in inches. All right. I have not been working in inches this entire time. That's okay. We'll stick with millimeters. I can always adjust at the end. There's a really easy way to do that afterwards. This one? Yeah. That's fine. We want the line right here to offset as well. So I've selected this arc. So I'm missing a couple lines here still. If that helps. Okay, so because it's looking like it's not connecting right now, this just means I'm going to have to offset them individually. So I'm going to go ahead and start with the offset with this point, this area right here. Reverse that. So we get this sort of offset for 0.25 millimeters. And then I'm going to go ahead and offset this slot right now, also 0.25. It looks a little bit messy. Oh, did I do that? Oh, okay. So basically, yeah, what I was trying to do in 2 steps, you can do in 1 step. What Colin just suggested was this button select chain. It thinks it's smart. And so it's trying to help you out here by doing a lot at one time. When you don't need it to do that much, you just need to do little by little. And then this is okay. That's fine, right? Yeah. All right, so we're going to go ahead and offset that much right here. It's 0.25 inches if you're working in inches. In millimeters, I'll show you how to change it to inches later. So now we go ahead and we have the general outline of it done. We need to go in and clean it up a bit. So first, let's add this little divide that we see right here. Or I guess before we do that, let's trim out all that we don't want so we can see a little bit more of a cleaner sketch. So this trim entity tool up here is pretty useful in this case. We're just going to go ahead and power trim all of this stuff that we no longer need. And we'll leave this for now. If we power trim this, it's going to cut this part off, and we want to keep this for now. But here we are. Now we can go ahead and say, okay, 0.25, we did all this. Let's add this 0.58 dimension. This is going to go from this line right here out here. So I'm, again, not connecting it on purpose right now. I want to see if it will end up together. I do not know, because there's nothing right indicating that this point is going to line up with this point. Once again, this is not in the same, it's not parallel right now, so I need to hold shift, click both lines, and then make parallel. Now I can add a dimension, a distance between the two, and make it 0.58. So we see that it isn't exactly in line, right? The points don't line up, and that's fine. We can go ahead and just do extend entities to make it so that does line up. And then we'll go ahead and go back and trim the extra bit off here. Now we can go down here and do the same for this area. We're doing 0.58 from this point right here. All right, 0.58. Let's see. I'm going to just go ahead and do a horizontal line across. Actually, I'm going to extend this line and make it hit this arc, because it looks like we do a fillet that connects with the arc we have up here. Now I'm going to make sure that these are perpendicular. So hold shift, click both lines, add the perpendicular. And I'm going to make it so that the dimension between this point down here and this one right here is 0.58. As such. So now that we've built all this, we can go ahead and finally trim out the last bits that we don't need, which is right here. And you notice how this entire sketch is still fully defined, because we had the offset, which told it from the edges how far to go, and we added extra 2 lines, but did dimension those to the sketch, and we added constraints, so all of it is fully defined. Now, remember what I said before, the last thing you want to do is add the fillets. So we're going to go ahead and add those in now. We have our 0.125 x5. That means that we have 0.125 radius fillet, and we do 5 of those, so 1, 2, 3, 4, 5 here. So 1, 2, 3, 4, 5 in this, and then 4 of them in here. So we're going to go ahead, entities to fillet, and clicking, okay, 0.25, there you go. Oh, sorry, it's 0.125, not 0.25. There we go. So that's like a sanity check. Yeah, as Colin said, I looked at it and I was like, this does not look right. So I just sort of double checked my numbers to make sure that everything lined up the way it should have. And then one thing I noticed while I was working on this just now is that this right here, in fact, is not offset. So I need to fix this point down here at the bottom right. So I'm going to select yes to all that. But I need to fix this right here. And that's super simple. I'm just going to go ahead and extend this line out a bit. Go ahead and extend this line down. And then we're just going to trim out the extra bit. And then we're going to, yeah, so we're going to click it and make it horizontal. And now it's fully defined. And now we can get rid of this extra bit right here. And we need to add the fillet to this bottom right corner. So we're going to add one more fillet down here, 0.125. And we're good. Is everyone here? Raise your hand if you are not here. All right, I feel like someone's lying. Okay. Did I speed through that way too fast? I can pause for a few minutes if everyone wants to catch up to get to here, or I can continue on. All right, pause. All right, I'm gonna pause for like 4 minutes, and raise your hand if you need help to get to where we are right now, and then there's 5 of us that will walk around and help you guys out.
Hey guys. Okay, so something kind of cool that instead of drawing these lines, like these horizontal lines, you can actually, under the trim entities feature, you have extend entities. So if you so what it does, instead of what a trim entity does, it actually extends the line until it hits another entity. So if I clicked here, it actually extends the line till it hits this center line here, which is the entity in this case. Just a kind of cool tidbit. Instead of having to draw those lines, but yeah.
All right. I realize that not all of us are here yet, but in the interest of time, what I'm going to do is I'm going to keep going through this and talking through it, mainly for the recording. So if you guys want, it's totally cool to just sort of pause what you're doing, watch while I go through the rest of this part, and on your own time, go ahead and try to finish it. And then we'll have the recording up by the end of the week, and you can look back and finish it alongside the recording if you can't do it on your own. But for the interest of time, I'm going to go ahead and keep working through this part. From here, hopefully I finish the part. We'll see if I can get all the way to the end. For reference, also, I want to point this out. This is my first time doing this part. So while you see me working on it, it's me thinking through how I would do it as well. So it's real time. I'm in your boat right now where I'm looking at it for the first time and trying to figure out how exactly am I going to do this. So we're here. We have this half done. That's great. Now we can easily just mirror it over to the left side. We're going to select. Okay. I like one sketch. Easy to see. I'm a one sketch type of guy. All right, we're going to go mirror entities, and we're going to mirror about the center line right here. And once it gets really green and really ugly, you can turn that off and just turn off sketch relations so it's a little bit cleaner. So now we have all this done, and the last thing we need to do is add the fillets at the top left and top right corner. That's going to be the radius of 1.25. Oh, this is going to be no, okay. All right, those fillets are added. And looking at this, it looks like the majority of this part has now been finished, at least for the base. The majority of the part of the base has been finished. So we're talking about this right here is finished. I'm going to go ahead and extrude it now just to get something going on the page. So I'm going to look for somewhere that tells me the depth of extrusion here. Right here, this says 0.25, and this is indicating the base. So we're going to go ahead and features, extruded boss base, click this area, go up by 0.25. Okay. Do you doubt me? What? No, I just like seeing it. Oh. All right. Anyway. Next up we need to do is this lock body. So, it's like one of the things you think about when you're designing a complicated part is the order in which you design the steps. There is this peg in the middle that I have to add. I have to add this lock body. No. I have to add this peg right here. I have to add this lock body and this shackle right here. So the idea is, which one do I do first? Looking at it right now, I want to start with the easiest and work my way up. So the peg in the middle is going to be the easiest thing to add. It's just a single circle, extrude upwards. So we're going to do that first. Okay. So part of this process is we're trying to show you guys all the different features that can go into making a part. And as a result, I'm going to be using something a little more complicated. Generally, probably don't have to use this feature, but I'll be doing it using a revolve. So looking at the planes, it's going to be hard to start a revolve because there's no plane that goes directly in the middle. So I'm going to have to create my own. So I'm going to go up here, reference geometry, click plane, and I'm going to make a plane I'll make a plane between the left and the right one to make it in the center. So I click both faces, and now there's a fully defined plane that's directly in the center of this part. So go ahead and click yes on that. Now I have a new plane. I can go ahead and sketch on the plane. So I click left on the plane, and it opens up the sketch. Now I have the origin here, and I have the other side here. I know that the circle is going to occur in the center of this rectangle. That I know because the center line right here, as we determined prior, is in the center of the rectangle. So I'm going to click view orientation, go to normal 2, which again puts me back in the plane. Create a center line from left point to the rightmost point. And now on the center line, there's a midpoint, and I'm going to create another center line that goes from here up. That's just to give me an idea of, okay, this is the axis I'm going to revolve around. Now I want to create the actual peg itself. So I'm going to look at this sketch because this gives me a pretty good idea of what to revolve. And I want to draw just half of it. I could do the entire thing and revolve about 180 degrees, or I can do half of this sketch and do a full 360 revolve to create the entire cylindrical piece. So I'm just going to do the one I mentioned after, which was the 360 revolve. So I'm creating the general outline. It does not have to be perfect by any means. It just needs to be the idea of what we're trying to do. Now adding the dimensions, we see that this is 3 inches from the top down to the bottom. And then we see that this is 0.125 right here. Also, if you have any questions while watching me do this, feel free to ask. I'm more than happy to pause, answer some questions. All right, now we add 2 more dimensions. We have 0.2 from the center to the first outside boundary, and then 0.375 to the second one. So right here, this is 0.2. And then from here to here, this is going to be 0.375. And now, I just double check, look at the bottom right. It says fully defined, so that means we're good to go. We'll go ahead and do a revolved boss base. We click the area. And it's sort of, it's not super smart all the time. Like, it's revolving it this way when I want to revolve it the other way. So I just click the axis of rotation, change that to this line. And now we have the circle that we wanted to make. All right. Next up, we finished the peg, we finished the base. Now let's start looking at how to make this padlock part. So what are some things that we can identify really early that might help us going down the road? The first thing I see when I look at this is I notice that this is an angle right here. This is not just a straight square rectangular prism, it tapers inwards. And that's something you have to consider when designing this. Okay, there's a few different ways you could do this, but the way I'm choosing to go about this right now is I'm going to do a loft. It's going to be between, we're going to make 3 planes. The first plane is going to be this. The first plane is going to do this part right here. The second plane is going to do this. So 1 to 2 is going to be this area, this line. And then 2 to 3, this is number 2. This is going to be number 3, and then we'll get the rest of the body done that way. Does that make some sense? Or is someone confused about what I mean by how I'm going to loft to this? Does anyone not know what a loft is? All right, cool. So let's look at see which place we're doing this. We're doing it over here. So I'm going to go ahead and create a reference plane off of this face. When you make a reference plane, there's varying levels of complexity to it. The easiest one is if you're making a plane parallel to another one, like I'm doing it right now, or if you're making a plane between 2 other sides or 2 planes. Those are really easy to do. When you get into making reference geometry off of angles, it gets a bit more complicated, but we'll get into that later down the road here, I think, in this part as well. I'm going to try speeding up a little bit because we are running out of time. So, all right, plane here. It's giving me a distance, but I don't want a distance. I want it to be coincident, so I'm basically making a plane on this face. So right here we have a plane. I'm going to make one more plane now, reference geometry, based off plane 2. And this one I'm going to be pushing out a little bit further. So looking at one of these drawings, looking at here, this is 0.25. So the distance for this is going to be 0.25. And then the third one is going to be 1, so 1 inch right here. So once again, reference geometry plane, it's 1 inch from plane 3. So now we have our 3 planes, and now we can start adding our sketches. So I'm going to first sketch on plane number 2. And this sketch is going to be, let's see here. Okay, 1.250. That's the height of this back one right now. So we're gonna make a sketch that goes from this corner up 1.25. So 1.25 up like that. And then across, it should be in line. So I'm just going to make sure that I go view orientation, normal to, and then that these lines right here are actually in line with my sketch. I can do that by holding shift, clicking both lines, making them collinear, and now we're good. So just try dragging a corner. It's fully defined. It says at the bottom right, fully defined. That's good. Next up, we're going to look at the next plane, which is plane 2, or plane 3, I should say. And we're going to look at this sketch. And this one is going to be the exact same, I believe, and then it tapers downwards. So I'm going to draw, I'm actually just going to click this sketch outline right here. And there's a feature called Convert Entities. So if I click the entire outline, go up here to Convert Entities, it will basically take everything from that previous sketch and put it into this sketch, everything I selected. So now we have this sketch done. Exit. And the last sketch is going to be a little bit different. Looking here, it's in the center between the top and bottom, and it is, so it's 0.375 from the top. Oh, okay, 0.375 from the top and from the bottom. Yeah. So I'm going to go ahead and do a center rectangle for this one. And go ahead and start dimensioning this. 0.375 from the top. And then to make things simpler, I can take the midpoint here. So I'm going to find the midpoint by holding my cursor over the line, clicking the midpoint, holding shift, clicking this, and finding the midpoint here, making that horizontal. So now that's in between. And next we just find the distance from left to right. And for that, that is going to be all right. Okay, from the side? Oh, okay, that makes sense. All right, so yeah, get it by offset as well, and that goes for this. So we apologize for some of the mistakes that we find in these. This was made by one of us, and so it's not going to be perfect, but close to it is as good as we're going to get. All right, this is fully defined. So now we have our thing ready to be lofted. So we have 3 sketches. We go ahead and do features, lofted boss base. Everyone hit all 3 of them. And actually, it skipped one of them, so we're going to make sure we hit that one as well. So it's sketch 2, sketch 3, and that one. So it does this, let's see. Hmm? It is selected. That's fine. Yeah, why is it curved? That's two lofts. Okay, sure. So we're gonna loft that together, and then we're gonna go ahead and take sketch this one and loft it with this one right over here. And that'll give us what we're looking for in terms of size. Now we want these planes, we don't want to see these planes anymore, we're just gonna go ahead and hide those. All right, we're almost done, a little bit left. So we look and we're gonna add in these pegs real quick. So that's on this face, that's 0.25 from the bottom left corner. So I'm clicking edit sketch, and now I'm just gonna go ahead and do one hole, and it's gonna be 0.25 from this bottom corner. And I'm going to linear pattern that across the face. And because of the direction, I'm not sure what the axis is. I'm just going to go ahead and click this direction so it knows that it's going in this direction. And I'm going to go ahead, do dimension that, do 5 instances of it. 10 millimeters is way too much. And so we're looking at, oh. Sorry about that. All right, let's go really fast. So how far apart are these? Let's see. 0.75, 0.625. All right, I'm guessing it's this one right here. No. But what's the spacing? Is it 0.25? What's the spacing for the linear pattern? All right, so I'm going to make the pattern. It looks like it is approximately 0.5. Let me see if this is correct. All right, I'm going to skip this part just because it's a little more complicated. We'll get back to it. We'll upload the final solution to the YouTube channel and send it out to you guys as well. Just because it's 9 o'clock, I want to finish it up as quickly as possible. So I'm going to skip and go ahead and just do the sweep to end off our features. So the last thing I want to do is create a reference plane between the top and bottom here. So reference geometry, plane. I'm going to make a plane between here and here. And on this plane, we're going to go ahead and sketch a line. We're going to sketch this idea right here. And that's super simple. We just do a line from this end, and then we do another line. You're right. All right, so one thing he said that reminded me, if you go on the line here, and then you go off of it, and you go back onto the line, it now creates an arc. Or I guess that didn't work, but what he said was, yeah, you can make an arc from a line, which is useful, very useful. All right, now we want to make sure that these are tangent, so this is going to be tangent. They are? Oh, yeah. Okay, so it says tangency right here, this green thing. And then we're going to go ahead and check the dimensions. So we're saying 1.5 from the end. This is 1.5. And then we go ahead and do a circular sweep. And the dimension of the circle is going to be 0.375. That's the dimension of the circle. And we're saying it's also 0.5 from the end. So from this point right here, 0.5 from the end. And same for the other side. So this is 0.5 from the end. All right, and the last thing we do is go to features, we go to sweep boss base, click the path that we wanted to take, and then we're doing a circular profile, and the circular diameter is going to be 0.375. All right, and there we have the majority of it done. There's a little bit we didn't get to, which is these pegs, but we'll send out the final solution later on. This recording will be posted to our YouTube channel, and then if you guys want to follow along there, you can. And if you do follow along and you have questions, reach out to us on Discord, and we'll be happy to answer them. So that ends this part modeling and this workshop. But before we wrap everything up, are there any last questions? Yeah. Oh, you're talking about this triangle over here? Yeah, so I skipped this as well. What you're going to need to do is create a reference geometry from this point right here, from a line to this, and then you're going to extrude into it. It's a triangle, so it's legitimately like, here, let me see if I can mark up. Yeah, let me show you guys from this point of view. So this is something you're looking at from here to here, going down like this. And then this gets extruded outwards a bit. Does that make some sense? So that is sort of what you're looking at with, that's this little triangular bit you see down here. You see a tiny bit of it here, and then you're also seeing it in this line right here. So it's a little bit complicated to see what this should be. All right, any other questions? Yeah. I'd say like a 5 or 6. I think what it is it gives you a good overview of all the different features, but you're not gonna have something this complicated on the exam. The exam is a lot simpler. It uses only a few features per part. So this is just basically an amalgamation of everything. I recommend doing more practice problems that are simpler. If you have the time to do more of the simpler ones than doing this. This is just a visual representation to show you how you can use all the features in a part. And it also shows you that you can build the same thing in different ways. That peg in the middle I did with the revolve can be done with the boss, with the extruded boss. The loft, can be done extruded boss, or it can be done with the loft. Like, you have different ways you can go about building a part. It's really up to you and sort of what the design calls for.
Yeah, because for example, the way you constructed the angle version the angle cap off,
Yeah.
you constructed it by constructing one off so you can make the column go, right?
Yeah.
Something I feel like I would do if it would be allowed is maybe make a box and then use extrude cut to cut it at this angle.
Mhm.
Kind of like the taking the away from the box into the
Yeah, that is possible. Actually, with extruded boss, they give you an option to taper. It's called draft, I believe. So it automatically creates this type of shape when you do an extruded boss if you add like an angle to it. But it's also given, what dimensions are they giving you? Are they just telling you a few and then it's assuming that you loft it? If they give you the angles, then you're able to do the extruded cuts that you're talking about. But you need a little bit different information for different purposes. That would work though. It might take a little more time, but it is a possible way to construct the same thing. Yeah. If it's overly defined? Mm-hmm. So sometimes what happens there is there's a constraint. There might be like a constraint that's stopping you, so you want to make sure that there's no tangencies or coincidences that you're overlooking. And then there might also be, like when you do the extra dimension, do it like it's driving and see where it tells you that it's overdoing it. And then you can look at those dimensions and seeing maybe you're missing, like an arc, it's not supposed to be a center arc, but it's showing as a center arc instead of a tangent arc or something. Like, small things can stop you from being able to continue in the sketch. But that's just one of the small things. You just have to look through your sketch and find it. Yeah, so what Colin is saying is, instead of, when I did this, I did the entire base. Yeah.
So what Suraj did is he created all of the parts on one sketch here, and then he just extruded that. But one thing that I would do is, so I would just, before I create like all of the details that he had here, I would just I would create the outside, and then I would create the sketch right here, and then let me real quickly show this. That way I can just like project this on here. And then I would create on a separate sketch on the top these right here, using the same method he did for the other thing. And then I would extrude cut this side right here. Pretend like this side like doesn't exist, because I would just create it on one side in order to like prevent what you did, because if it's not letting me mirror it in one sketch, I would cut it through and then go through all, so I just go through the entire part. And then what I can do is, using the mirror, I'm going to select the right, oh. He didn't create it in. Oh, right. Okay. So if I want to mirror it around this point right here, I have to create a reference plane. And so I'm going to select this and select this. So in SolidWorks, when you select two planes and you're trying to create a plane, it'll create a plane exactly in the center. It'll create a midplane. So I'm just going to make that. This is just like a construction plane, so I'll use that for my mirror. Then I take the mirror, I select my plane that I just made, and then the feature that I need to mirror is this cut extrude. And so it's going to cut it on the other side now. Does that make sense? How I did all of that? Like, because I normally, when you create like a rectangle or something, you're going to want to try to have it mirrored around that center. But if you don't, you can always create a plane like this. And then this will get you the exact same result as if you just like extruded using that. Oh, yes.
All right, we'll be happy to answer more questions, but again, in the interest of time, we're going to go ahead and get to the end of our workshop, and we'll see a bit after if you want to ask us questions. Abe, do you want to hit the end recording? All right, we ask that you all could just go ahead and fill out our feedback form real quick while we finish this up. That just helps us understand how we can improve these workshops for y'all. And then also, we'll send out the Discord later.